Hello friends, welcome back to our channel Ahatin Edu-Care. Our channel provides online learning materials of maths and science from class 8 to class 12. Please visit our channel playlist section to get benefits of this free learning materials. Okay friends, coming back to our topic of discussion which is functions. This is the fifth lecture of functions. Till now, we have covered what is a function, function as a relation, function as correspondence. Then we have seen what is domain, codomain, and range of a function. We have also discussed real valued function and how to find domain and range of a real valued function. Then we have also discussed some special type of functions under which we have covered modulus function, greatest integer function, least integer function, fractional part function, exponential logarithmic function, and many other functions. Okay, friends. So those who have not gone through previous lecture, please follow the link given in the description box, or you may find these lectures in the playlist. Okay, friends. So go through those lectures before going through this part. Today, our topic of discussion is mainly operation of real functions. So, under operation of real functions, we will discuss addition, product, difference, quotient, and multiplication of a function by a scalar. Okay, friends. So, we will start with operation on real functions. Operations on real functions. Okay. So, in under operation on real functions, we will start with addition. So if fx and gx are two real functions, then their sum is defined by fx plus gx. So we can write let f of d1, which is domain of f, and its range is given by r, and gx is another function g with range or domain is d2 and range is again a real number. Okay, so these are two real functions. Their sum f plus g is defined as that function from d1 intersection d2. So domain will be d1 intersection d2 of f plus g. Okay, two range will be r that associates each x is an element of d1 intersection d2 to the number fx plus gx. Okay, so domain will be d1 intersection d2. So if f and g are two real functions, Then f plus g is a function from d1 to d2 to r such that so we can write f plus g of x is equal to fx plus gx for all x is an element of d1 intersection d2. Okay, so this is how we perform the addition of two real functions. Next, we will discuss product of two real functions. Okay, so how to perform the product? So here if f and g are two real functions with d1 and d2 respectively are the domain of f and g, then their product f into g is a function from d1 intersection d2 to r. Okay, so we can define this as let f d1 to r and g d2 to r are two real functions. Then their product fg is a function from d1 intersection d2. Domain will be d1 intersection d2 to range will be r and is defined as and is defined as fg of x fg, let me write it clearly, fg of x equal to fx into gx for all x is an element of d1 intersection d2. Okay, so this is a product of two real numbers. Now let me clean this. Next we will discuss difference or subtraction of two real functions. Difference or subtraction of two real functions. Okay, so how to find the difference of two real functions? So again, if f and g are two real functions with domain d1 and d2 respectively, then their difference will be indicated denoted by f minus g or fx minus gx and domain will be d1 intersection d2. Let f d1 to r and g d2 to r are two real functions. then the difference of G from F. G from F is denoted by F minus G and is defined as F minus G of X equal to Fx minus Dx. Okay, with domain D1 intersection D2. Okay, friends. So we have discussed addition, multiplication, and subtraction. Next, we will discuss division of quotient. Fourth one. Okay. So let F D1 to R and G D2 to R are two real functions. Then quotient of F by G is denoted by F divided by G, and it is a function from D1 intersection D2 minus X such that denominator Gx equal to 0. So all those x which keeps Gx equal to 0 shall be excluded from the domain of F by G, and range will be R defined by defined as F by G of X equal to Fx by Gx for all x is an element of D1 intersection D2 minus x such that Gx equal to 0. Okay. So next we will discuss multiplication of a function by a scalar. So let me claim this. So multiplication of a function by a scalar. Okay. So if a function is f d to r, so let f d to r with domain d and range r is a real function, and k be a scalar, k be a scalar or real number, we can write a real number. Then the product k into f, kf is a function from d to r d to r, okay, and is defined as k f of x equal to k into fx, okay, for all x is an element of d. So we have discussed addition, multiplication, difference, quotient, and multiplication of a function by a scalar. Next, we will discuss reciprocal of a function. So if f d to r is a real function, let f d to r be a real function, then its reciprocal 1 by f is a function from d, domain will be d minus x such that fx equal to 0. So all those x will be excluded from the domain of real function for which fx equal to 0, and range will be R and is defined by 1 by f of x equal to 1 by fx for x is an element of d minus x such that fx equal to 0. Okay. So this is how we can find some difference product, quotient, and reciprocal of a function. So if there are many functions and we have to find f1, f2, or there is a function, we can write note. If a function is f, if f d to r is a real function, okay, and n is the element of natural number, so we can write f f f if it is repeated n times, okay, n times f of x, so it will be multiplication of fx n times, okay, it will also be n times, or we can write this as fx to the power n. Okay, for all x is an element of domain of fx. Okay, friends. So we have discussed addition, multiplication, difference, question, multiplication by a scalar, and reciprocal of a function. So let me clean this and then we will discuss some problems based on operations. Okay, so please write down a problem. Find the product of identity function and its modulus function. Okay, so under the special types of function, we have already discussed identity function and modulus function. So if f and g denote identity and modulus function respectively, then f r to r domain and range of identity function will be real number to real number such that fx equal to x for all x and g r to r such that gx equal to mod of x. Okay, so fx equal to x and gx is equal to mod x for all x. Okay, so f and g we can see has the same domain. So domain of f and g will be R only. So as f and g has same domain, therefore we can write d1 intersection d2 is equal to R, all real numbers. So we can define the product as f into g of x equal to fx into gx, and this x mod x. Okay, so mod x will be x when x is greater than or equal to 0 and minus x when x is less than 0. So x into x will be x square if x is greater than equal to 0 and x into minus x because mod of x will be minus x when x is less than 0. So it will be minus x square if x is less than 0. Okay friends, so this is the product of identity function and modulus function. Then next we will see, please write down the problem. We will discuss all. A function is given as, let's write down. F and g are two real functions given by fx equal to 1 by x plus 4, and gx is given as x plus 4 to the power 3. Then we have to find, first one is f plus g, so addition. Second one is f minus g, subtraction. Third one is multiplication, f into g. Fourth is quotient, f by g. Fifth is scalar multiplication, which is 2f. Then sixth, reciprocal function 1 by f, and seventh, reciprocal of g. Okay. So all we have to find this. So first, fx and gx are given. So we can define what is the domain of fx and what is the domain of gx. So fx equal to 1 by x plus 4. So what will be domain C? Denominator shall not be 0. So x plus 4 is not equal to 0, or x is not equal to 4. So we can write d1 equal to r minus 4. Okay, as x plus 4 is not equal to 0. Then we have to find domain of gx. Gx equal to x plus 4 to the power 3. So we can clearly see domain of gx will be all real numbers. Okay. So domain of f and g. So for all the operation, we can see domain of f intersection domain of g, or d1 intersection d2 will be equal to r minus of minus 4. So now we will start with f plus g. So if f plus g we will define, so its domain will be from r minus of minus 4 to r. Okay, and f plus g will be defined by f plus g of x equal to fx plus gx. So we can write 1 by x plus 4 plus x plus 4 to the power 3, and this will be x plus 4. So this one will be 1 plus x plus 4 to the power 4 divided by x plus 4. Okay, with a domain r minus of minus 4, and range will be r. Second one, we have to find f minus g. F minus g from r minus of 4. Domain will be r minus of 4 to r, is defined as f minus g of x equal to fx minus gx. So it will be 1 by x plus 4 minus x plus 4 to the power 3. Okay, so this will be 1 minus x plus 4 to the power 4 divided by x plus 4. Okay friends, so this is f minus g. Next we have to find f into g, fg. So let me clean this. So next we have to find f of g. So how we can find f of g? See, this is third one. So f of g domain will also be r minus of minus 4 minus of minus 4, okay, and range will be r and is given by fg of x, f equal to fx into gx. It will be 1 by x plus 4 into gx is x plus 4 whole cube. Okay. So from this we will get x plus 4 square. Okay. So next one, fourth. Fourth we have to find quotient or f divided by g. So from this we can see f of g, f by g. So domain, what will be domain of f by g? See, if we divide by dx, then dx should not be equal to 0. Okay. So we have to exclude all those value of gx for which dx equal to 0. So we can write dx is not equal to 0. It implies x plus 4 cube is not equal to 0 and it will give x is not equal to minus 4, but fx is also defined when x is not equal to minus 4. So domain will be r minus of minus 4. So domain of f by g will be equal to domain of f my intersection domain of g minus x is such that gx equal to 0. So from this we will get r minus of minus 4. Okay. And function will be given as f by g of f by g of x. So f by g it will be from r minus of minus 4 to r, and f by g of x will be equal to fx by dx. So fx by dx, and fx is 1 by x plus 4 and dx is 1 by x plus 4 to the power 3. So it will be 1 by x plus 4 to the power 4. Okay. So we have calculated f by g, fg. Next we have to perform scalar multiplication. So let me clean this. Okay. Okay. Gx also I have erased. So gx is given as x plus 4 to the power cube. Okay, and what is the range? Range is defined as R. Okay, domain is R. Range is also R. Okay, this is a D2. So next we have to find fifth one, 2f. So 2f will be, as domain of f is r minus of minus 4. So its domain will also be r minus of minus 4. R minus 2r, and is defined by 2f of x, it is equal to twice of fx. So we can write fx is 1 by x plus 4. So 2 by x plus 4 for all x is an element of r minus of minus 4. Okay. Next one is sixth one, in which we have to find reciprocal of f. So 1 by f, as we can see, fx is not equal to 0 for any x is an element of r minus of minus 4. Okay, x is an element of r minus of minus 4. So 1 by f, or will domain will be r minus of minus 4, and range will be r, and is given by 1 by f of x equal to 1 by fx. So 1 by x plus 4. Okay, it will be x plus 4, and domain will be r minus of minus 4. So next we have to find 1 by gx. So let me clean this. So we have to find 1 by gx. So seventh is we have to find 1 by gx. So gx should not be equal to 0. Okay. So gx equal to x plus 4 to the power 3 equal is should not be equal to 0. From this we will get x should not be equal to minus 4. So 1 by g of x will be defined from r minus of minus 4. Minus 4 should be excluded, and range will be r, and is defined as 1 by g of x equal to 1 by gx, and this will be 1 by x plus 4 to the power 3. Okay, for all x is an element of r minus of minus 4. Okay friends, so we have seen how to calculate, how to perform addition, multiplication, subtraction, and division of two functions or two real functions. Okay, so next we will see one more problem. So find the domain of the real function. Please note down. Let me clean this. Find the domain of real function. fx given by fx equal to under root 1 minus mod of x divided by divided by 2 minus mod of x. So it is 1 minus mod of x divided by 2 minus mod of x. So first we have to find, as see, fx will be a real function. Find domain of fx given by, or we can write domain of real function fx. A real function fx given by fx equal to, so how to find the domain? See, we have to represent this on number line, then whatever is under root, that has to be positive. So as fx is given as under root 1 minus mod of x by 2 minus mod of x. Okay, so we can clearly see if we represent this on a number line. Okay, so domain will be all the values of x satisfying. Domain will be all x satisfying 1 minus mod of x divided by 2 minus mod of x is greater than equal to 0, and 2 minus, we will write, and 2 minus mod of x should not be equal to 0. Okay, so we can see some values we can write here. X may be minus 1 or from minus infinity to plus infinity. Okay, so 2, 1, 1 or 2. So next we will check with mod of x, or 1 minus mod of x divided by 2 minus mod of x is greater than equal to 0. It implies mod of x minus 1 divided by mod of x minus 2. Okay, this will be greater than 0. From this we may get mod of x is less than equal to 1, or mod of x is greater than 2. Okay, so when mod of x is less than 1, both numerator and denominator will be negative and the ratio will be positive. And when mod of x is greater than 2, both numerator and denominator will be positive and ratio will be more than 0. So from this we get x is an element of minus 1 to 1, or x is an element of minus infinity to minus 2 union 2 to infinity. X shall not be equal to 2 from here. We can see this. From this we can write mod x is not equal to 2. Okay, or x is not equal to plus minus 2. So it will be open at 2. So if we represent minus infinity to minus 2, then minus 1. Okay, so from here we can write x is an element of minus infinity to minus 2 union to infinity union minus 1 to 1. So minus infinity to 2, it will be plus, then minus 2 to minus 1. Minus 1, it will be negative. Then minus 1 to 1, it will be positive. Minus 1 to 1, it will be positive. Then next, if we see from 1 to 2, it will be negative, and 2 to infinity again, it will be positive. Okay, so our domain will be domain of f. Okay, domain of f equal to minus infinity to minus 2. This number line indicates ratio, okay, or sign of 1 minus mod x divided by 2 minus mod x. Okay, this shows the sign of 1 minus mod x, and domain is minus infinity to minus 2 union 2 to infinity, 2 to infinity. Let me write it clearly. So 2 to infinity union minus 1 to 1, but it will be closed at both ends, minus 1 to 1. Okay, friends. So this is how we solve problems related to functions. I hope all of you have understood this lecture. If you have any query, please let me know in the comment box. And if you have seen the full video and liked it, please like the video and subscribe our channel Lahajinki Educare if you have not already subscribed. Also press the bell icon button so that you will get notification when next video will be uploaded. Okay friends, thank you.